Well, good afternoon, everyone. Thank you so much to the conference organisers, to Alessandro and Eugenio, for inviting me here. I've been involved with Alessandro now for about 3 years, programming sound banks for his C-Sound apps. Mostly ICSC, which is an incredible recreation of the EMS VCS3 synthesizer from exactly 50 years ago. So it's 1969. So during that time, I've been exploring ICSC very deeply, and one of the original drawbacks from the original machine was that it has a trapezoid envelope.
Is there a cell phone somewhere or something? Which one? Okay, thank you very much.
Thank you, Alessandro. Okay, where was I? Oh, yeah. The VCS3 original hardware synthesizer had a trapezoid envelope, which makes it very difficult to create staccato or punchy envelopes, although it is so good at doing other things. So I had reasoned that as ICSC is so close, it also suffered from the same issue. But as it can accept an audio input on two separate channels, one channel could be used for the control voltages from the keyboard, and the other could be used in other ways. ICSC can accept audio wave files, sample files, to play instead of an audio input. You can have either. So it occurred to me that an audio file, even though the vast majority of people consider that it contains audio, but in fact it doesn't. It actually only contains a description by the use of samples. I'm sure everyone here knows that. So, okay, I don't need to elaborate too much on that. But as a result of this, the implications of this is that it allows you to record any change in voltage. So it doesn't necessarily have to be an audio voltage that's changing, because it's a change over time. So we can repurpose an audio file to contain something else. It doesn't have to contain audio information. So again, if we go back to the original sample file, in this instance, this is a sine wave with an envelope attached. So the way we perceive that, the way we perceive the amplitude of that, you can kind of see here. This is a bipolar, but if we just consider the positive value, it then begins to describe much better how the envelope is changing over time. You can see there how this is our perception of how the envelope changes. So this then can be represented by individual samples which over time describe how the envelope changes. So you can load this in to ICSC as an audio file. ICSC, or in fact any processor, doesn't care what's in the audio file. It just considers it's an audio file, it's an audio format. So just one of the quirks of the original hardware is that it inverts the signal, so on the screen it is inverted. Okay, so if we come back to here, we can see there's a rate parameter which allows you to set the playback speed of the audio sample, and we can use this to set the duration of, for instance, this example, which is a percussive envelope. So we can use the rate of playback to decide how long that the envelope is going to apply. We can then use the amplitude of the incoming wave to set the amount of modulation that we could apply to whatever destination that we choose via the matrix. Okay, so now I'd like to show that with a live demonstration. So here we have, well, above we have a sine wave, which is a very low frequency sine wave. It could be considered audio, but a sub-audio rate. So it can then be used as a low frequency oscillator. And then the bottom is the envelope, which can be set to trigger. So what you heard there was the envelope changing the filter frequency, which has been set up here with the green pin. So the green pin is taking channel 2 information, which is then applied to the filter frequency. Then the red pins are taking the channel 1 and applying those to both oscillator 1 and oscillator 2's frequency. So if we come back, I can manipulate some of the parameters in real time. So that's obviously increasing the modulation. And now we can adjust the rate of the envelope. And we can adjust the amount of modulation that is occurring via the input level, which is input level to channel 2. So we can see it moving here. Okay. Okay, so now that we have that demonstration, the fact that we're using an audio file means that we have extremely accurate programmability within that, because you can zoom in to sample, and have an extremely high resolution, dependent only on the sample rate of your audio file. So it means then you can describe whatever type of envelope or structure that you want within that. So for automation, usually you would turn a knob to bring up the modulation, but in this instance, the modulation on the top is starting off at 0, and then to zoom in on that, you can create whatever type of structure that you want for your modulation. In this instance, we have we are modulating here, and that is changing the pulse width of oscillator 2, and it's doing it in any way we choose to do so. So I recently did a commission for a guy who was doing a recreation of Edgar Frost's Ponophilia, and it was necessary to create envelope structures in order to recreate the piece. We can see here, it's very obvious, I think, that as the loop repeats, it recreates the structure of the original piece. And really, in order to create these files, it is merely, you just use an audio editor, like Cool Edit Pro or whichever one that you go to. You can also, for example, in a DAW, you can have a maxed file, which is an audio file that has every sample is at maximum, and you can then sculpt using the envelope points from within the DAW. So then you could then send that audio file out to a destination, and it would then change it automatically, just by using the DAW parameters as well. So there are lots of applications. This is another example of a for example, a brass envelope. And this example is where you can also take the structure and modulate pitch. And this effectively could be as long as your memory can hold. So here we have, on the bottom, we have an amplitude destination, and on the top we have a pitch destination. And if you notice that there are curves, which is a way of programming pitch bend, can easily be described in that way. The top spikes are for reducing the filter to 0 so that it creates a blank. So. that's basically it. So, in conclusion then, once the description is in the audio file format, it can be processed with audio opcodes and transmitted using standard audio buses. But the fact that it is an audio format file means that you could apply a delay to an envelope, for example. You could apply any type of audio processing to the control voltages that's there. So it opens up another sphere of control or for manipulation. So you could start off, not only would you be manipulating sound with certain ways, but you can actually manipulate the envelopes and structures as well, because it's in an audio format. They can also be mixed. I don't think I've got time to show that, but it's possible, for example, to have one instance of ICSC which is the main synthesis engine, and then you could have others that feed their changes into their outputs, their audio outputs. Then those audio outputs can be fed into the primary example in order to modulate destinations. So if basically what's happening is, in another one of Alessandro's programs is 8 matrix, and effectively what is happening is the audio is being sent out as being processed by 8 matrix and being sent into the destination. So in other words, the CV can then be mixed with a standard audio mixer. So it means that, you know, perhaps when there's multiple destinations, you could have a mixer set up where all the inputs come in, then you send out as a single feed, or you know, to wherever you want. So you could have, if you have multiple inputs, you can then blend them whatever way you want, just with a fader. So, but that's basically it. So.